Welcome again to the June session of Dr. Spotfire. My name's Neil Canungo. I'm your host. And for those of you that I hope you had a good Memorial Day weekend, a good long weekend. I can't believe we're in June already. This year is really just flying by. Today we have a really great session on top tips for R and Python data functions in Spotfire. Today, I am very pleased to introduce several data scientists from the data science team. We have two staff data scientists, David Katz and Vaibhav, and we're also joined by Adam Askowitz. So they'll be presenting on many different tips with Python and R for data functions, in particular, how you use it with Spotfire. Some might just be some general Python tips or R tips, but all in the context of how you can use Spotfire better. So our agenda today is we're going to start with Adam, who will be doing app building tips, and then we're going to move on to some performance and debugging tips from David Katz, and then some DevOps tips from Vaibhav, and he's going to show also some plug-and-play scripts. We've started a new data function library. We can grab lots of ML and stats and feature engineering type scripts to just help you out. And we also have some new features and data functions we're going to cover as well. But with that, let's go ahead and get started. And let me hand it over to Adam for some of the app building tips with data functions. Adam, you wanna take the wheel here?
Yep, thanks, Neil. If I could share real quick. So today I'm going to be covering a very useful tool for Python data function. That is using the Pickle library within Python. So basically what pickling is going to allow you to do is it's going to allow you to save any additional information in Spotfire that you might not be able to otherwise. So document properties have typical types that you can save in, but what pickling can do is it'll turn any Python object into a binary object similar to a blob in R and ter, and it'll save it and make it useful for later. So what I'm going to cover is I'm going to give you a little bit of context of where you might want to use this. So this is our wafer pattern detection dashboard that you can find on the Exchange. And here what we're doing is we're using pickling to save our model objects, our random forest object, so that we can use it for later. So the typical flow that you might have is at the end of a Python data function, if you're trying to save a model, you might use this pickle dumps function, which will then, if you then take this one variable and use it as an output of the Python data function, it'll be stored into a document property. As here you can see, stored model has just a binary value. And this will make it so that later in a different Python data function, when you load in some new data, you can simply just use it as an input and load it and have access to the variables that way. And then I can just show the result of what this will be. So let me turn now to Spotfire. So this is what this might look like. So I've just created basically a random forest model that's supposed to pick up when this one heart pattern happens in wafer data. But the important thing is what I do here is I click this run model button. And what this is doing is it's running this one Python data function that I have. This will use the sklearn random forest to load and basically create the random forest and then have it be able to be saved for later. So here at the bottom of this data function, what we have is stored model equals pickle.dumps RFC. RFC is random forest classifier. And this was what this is doing is it's taking that basically this sklearn model file, something that wouldn't usually be like readable in Spotfire alone, but it turns it into this binary format that can be stored as a document property. And why this is very valuable is because this will be saved. And now that I've created this one model object, sometimes you want to now use that model object that's been trained and use it on some new data. So if I go to this score new data page, what this is doing is it's accepting, when I click this run models on new data, it's accepting that document property as an input, and then it's loading it up and executing on new data. And this can be valuable not just for these random forest model objects, but this is really just a useful hack to be able to store any additional information in Spotfire that you might not otherwise be able to store. So, sometimes it's hard to write into a data table. And what this can do is if you just store some information within this Pickle binary object in a document property, whenever you use a Python data function, you can use that as an input and load it up and basically get that extra access to information. So that is just one useful tool, and it's basically the same thing as an R blob, but done within Python and the Python data functions.
Thanks, Adam. Yeah, I think this is I was really happy to have Adam present on the day, because if you are trying to build, again, an application and you need to store what you're doing or temporarily store what you're doing, whether that's a model or that is, certain objects like these wafer patterns, certain amounts of data or data tables, people might try to take that and write it back into a database or write it out to a CSV and then store that and access that. But really, you can just store a lot of that right into a document property if you're not using too much information. I mean, the document property can handle quite a bit in itself. I mean, it's not going to handle like gigabytes of information, but you can store all kinds of objects in there because the document property can handle binaries. So it doesn't need to be just a string or an integer, or those ways we use document properties for parameters and other ways in calculations that we traditionally use them for. So so the pickling is the way to do it with Python. It is in our documentation, something to check out, and also blob is a way to do it with tear. And throughout this next section, I'll go ahead and I'll find a blog post. We have a blog post on how to use a blob with tear and do this with tear. Thanks, Adam. Appreciate that.
Yep, thanks.
So now I wanted to actually hand off to David Katz, who I love working with. David, he's kind of a wizard when it comes to Spotfire data functions and R, and he has many different tips that he picked up along the way to help with debugging, parallelization, better compute times. But without giving away too much, I'll go ahead and hand it over to David. David, do you want to take the wheel here and show us some of your top tips with data functions?
Sure. Let me share my screen here. Thank you for that very generous introduction. That's very nice. So one of the things we face as we get more into using data functions is that there's more and more complexity, and we're passing more and more things from Spotfire into the data function. And ordinarily, that's not very visible. And so the purpose of this snippet of code, I have this in just about every data function that I work with. I can't do without it. And it is very similar to the pickling thing in Python, but this is R-centric for those of you who are using R. Now, the code here is just a demo. You can customize it to yourself, for yourself. But one thing that's necessary is to decide where you're going to save your R workspace. So when the data function first executes, the first thing I'm going to do is save to disk the entire workspace. And so first I just define a place to do that, and then I make it conditional on that that spot existing. And the purpose of that is so that if you give out that data function, presumably that won't necessarily exist. So the data function doesn't have to take that debugging step. Or alternatively, you could set it up with a switch and just turn on this step for debugging. But the main thing is that you're going to this save list of list. It's similar to save image, but basically it says all of your objects when you start up um, are listed here, and you're going to save it into this name, and this name can be customized for I'm often debugging many different um, R functions at once, so each has its own name, so they don't interfere with each other. And this just saves it to disk. And so what this is an image of the R workspace that Spotfire creates for you, where the data is populated in R format in order to continue the rest of your processing in your data function. And so the purpose here is really just to give you visibility into that, so you can debug it outside of the Spotfire environment. So if you're an RStudio user, you can read in this. This is what you have for the code to capture that in a separate R session. So you use the load command and load in the R data file that Spotfire wrote, and now you've duplicated that, and you can do that in any R GUI or development environment that you want to use. So one of the tips that I've just recently come upon is when you write R data, there's a couple of options. Well, this one is a long-standing one, because R has its standard format for R data objects, whereas TER uses, by default, uses a different format that has some efficiencies, but it's not standard. So if you're using TER from Spotfire, you have to have this clause, this parameter R format that is tells it to write in the standard R format, and I recommend using open source R for debugging. TER and open source R are highly compatible with one another, but one of the things that I wish TER had is debug and browse. And those are, very important debugging tools. And if you use RStudio, their debugging is dependent on those. So by debugging, by using this parameter and then debugging in open source R, you have these really wonderful debugging tools that you wouldn't ordinarily have. So this just becomes more important as you have more complex data functions that you're trying to do. And then recently I came upon this, is if there's a lot of data involved, of course, for testing, you might want to start with a smaller amount of data, but this speeds things up. At the expense of using more disk space, you get quite a good speed up by adding one additional parameter to this save function. So my practice is to have this command for loading, to have it in the text, but have it be commented out, because you don't want to do this except when you're starting a debugging session.
Yeah, and I mean, just to kind of hit this on the head with why is this so useful is, I mean, what you're essentially doing is you're trying to take, I mean, Spotfire has these powerful data functions, but the IDE, the interactive developer environment, is not as good as something like RStudio. And so you want to take everything in your R session or your TER session in your environment, and you want to be able to open that up in RStudio and go back and forth. So what this is doing is creating an R data file, and the R data file is kind of an environmental data file that you can open in RStudio, and that's going to bring in all of your data tables that you might have in your session. It's going to bring in any inputs and outputs that you have in your session, and then that allows you to use the RStudio IDE to then build your data function. So it's always kind of package everything up, move it over to RStudio, work with it in RStudio, and then bring it back and forth. You might find that when your data functions aren't working the way you expect them to, it's hard to figure out why is that not working. And it might be you don't know what output of a certain table is. You don't know if it's reading your Spotfire data the right way. and it gets hard to trace it. So I would say like all of our top data scientists, they use this method. It's basically a boilerplate code, just a code snippet that you just throw into the top of your script in your data function, Spotfire, and now you got an R data file exactly what Spotfire is working with in its tear session. And you can also move this throughout your code if you want to output our data at different checkpoints throughout your script.
All right, that's a good point. I've actually never done that, Neil. That's a really interesting point. Um, okay, so let's move on to what I call a gotcha, which this is not documented anywhere that I've seen. But the fact is that data functions actually are limited in a certain way, is that they own their outputs. And whether that's a table or a column, the data function that creates that table is tied to it within the internals of Spotfire. So one mistake that you learn this by bitter experience. You create another data function and overwrite that table, which is very convenient and seems to make a lot of sense. But you actually break the old data function. And you go back and you say, well, why isn't this old data function working? It used to work, but you've broken it because you've output to the same table or the same column. So there's a couple of ways to work around this. We talked about storing things in a document property, which is very, very handy, especially for tables of parameters that you might want to actually be writing to and manipulating. And as with pickling, there are limits on the size of what you can store in a data table, and so I try to limit this to rather small tables. But the primary workaround that I've found for this is you just decide that you're going to have one data function for one output table. And if you need to do different things, you create a code or a control, usually a document property that says, okay, well, this one is initialized and this one is processed, for example. Or whatever different functions you have. You might have a whole list of functions. You can put that into Spotfire as a dropdown, for example. Before you call the function, you say, this is what you want the function to do. And so you deal with it that way. Parallel processing is something that, we recently had some requests. How can I speed up my R data function? And this is actually really an R tip more than a Spotfire tip. But if you're using data functions, it's good to keep in mind that parallel processing works the same way when you're running in tear under Spotfire as it works open source R separate from Spotfire. So here's just a little code snippet. The thing that's a little bit challenging for people is that you have to have a working Java installation. Java, it doesn't get in the way very much, but it's used behind the scenes to start up these parallel sessions. So what parallel processing in R does is creates an array of independent R sessions, and it sends work to each one of them so that they can work in parallel. But that process of setting them up is actually helped along with some Java code. And so you have to have this environment variable set, or you can do it, as I've shown here, you can put it within your R code. And this is all done with the parallel library, where you first of all detect how many cores you have available, depending on your hardware. And usually I like to leave one so that the work doesn't interfere with other things you might need to do with your computer. There's still some capacity left for those other things. And embedded in this is this ability to run your testing in R or in tear. So you can test in this way to see which type of cluster you have access to, and if you have tear, you want to give some options to the Java setup code. So that's about the hardest thing. Once you do that, you have this version of lapply that does things in parallel, which is very nice. So you just think about it as if it's lapply, but it's parallelized. So each call to your function is mediated by the parallel cluster.
So what that's doing, just clarify for me here.
Yeah.
What you're doing is you're setting up several sessions, several R sessions in parallel, and that's stored into an array. And then are you using lapply to apply the function that you want to each of those
Yeah,
sessions?
this parallel lapply is like a drop. Once you've done the setup, it's like a drop-in replacement for lapply. So it works
Okay.
just like lapply, except it does each step, each call of your function on something in your list. Each one of these can execute in parallel. So suppose you have 100 regressions that you need to do. You set up the function that does the regression, and you have maybe a list of data inputs.
Mm-hmm.
That would be a typical use. And then you call this, and you get the output is comes back to your main R session as a list, and
Okay.
so you get a list of the results of executing each one of these data functions.
So you essentially have like a master session, and then you have these sub sessions, and they come back to the
Right, and
master.
I use the word array. That was not technically an R array. I just mean
Right.
that there's a collection. There's a collection of arrays in memory, a collection of R sessions in memory, and this is how you access it. You don't access those directly. You access
It's
it
not like a
through
list.
parallel lapply. So
And I think
I
this
think
actually
that's
about the
my
right
time.
approach.
Unless there's questions, I'll turn it back over to you, Neil.
Well, with that, I'll go ahead and do the proper introduction for you, Vaibhav, our next and final speaker. Vaibhav is one of our staff data scientists, and we worked together a bit on trying to figure out a robust but agile way to manage data function development across our team, and how to create reproducibility and documentation. And we thought we'd share that with you. We know that other organizations are the same and maybe their own methods, but we just show you the method we use internally at TIBCO. So with that vibe of, why don't I go off to you for a little bit of the DevOps side of things?
Absolutely. Thanks, Neil, for that introduction. So I'm going to go ahead and start sharing my screen. Cool. So I'm just going to start off with this internal effort that Neil was talking about and building these reproducible data functions. And what was our vision when we started out, right? And it was definitely to complement the new data function Flyout that's in Spotfire 11 and onwards. We also want to create these out-of-the-box, ready-to-use functions for various data science, analytics, and data manipulation use cases, right? And one of the key things to this also was to establish a process around this, is to kind of allow multiple developers from cross-functional teams to actually seamlessly come in and just write a data function and see that's being integrated into the product. So definitely right off the bat, we see we see some values around this, and one of them is expanding the analytics palette and the embedded data science capabilities within Spotfire. You also augment the breadth of Spotfire's advanced analytics capabilities with these data functions. So I'm going to jump into the process that we've defined here, and as Neil mentioned, our goal when we started out was to keep this as lean as possible. So we kind of broke this into like these 4 steps. The first was obviously to kind of define a list of these data functions that we're going to tackle, and I'm going to quickly just show you our internal, like how a ClickUp board looks like. And as you can see here, we have some of them that are being proposed, some that are in progress, and some that are being published. So it helps keep track. The other thing was how to go about development, and we had few ideas around this, but the best that's been working for us is this concept of Git flow architecture in terms of version controlling these. So we haven't exactly used the entire Git flow architecture. So just to keep this lean, we've kind of focused on just keeping a develop and a master branch. And the way it really goes is we have, we have n number of developers who work on their Python data functions. They could be working on their local branches, and then eventually all the data functions actually get committed to a develop branch. And this is where the entire team plus the reviewers have access to the data functions. So we even have kind of a folder structure of how we want the data functions to be listed out in the develop branch, which I'm going to show in a second. And then the idea really here at this stage is to kind of, have the authors develop the data functions and have other data scientists and engineers in the team kind of review these data functions in terms of usability and use cases, and kind of test out some of the edge cases of how this data function would work with a wide variety of data sets. So this is a very iterative process. So once the team reviews it, there's often some feedback. So the data function author would go back, incorporate these feedback, make these changes into the repo again, and at that point, it's really ready to go a step forward, which is to focus on documentation. And one of the things that we've been focusing a lot is documenting our data functions, and I'm going to go a little bit deeper as we move along. But some of the documentation, but this is just one of them, but not limited to. We have design documentations for our data functions, and also README files that pertain to what the data functions are, what their inputs and outputs should look like. Once we have the documents reviewed, it kind of just goes into a release cycle. And the release cycle basically involves uploading the data functions onto our typical community exchange and also onto our data functions library landing page. Once they're in there, we push the data functions from the develop branch into a master branch, and then we can have the legal approval for a public release. So I'm going to now start quickly jumping into some of these blocks, right? And the first one, I'm going to go ahead and kind of just show how our internal Git structure looks like. And as you can see here right now, right, oops, this was not supposed to happen. Okay. All right. Oops, no idea why. Okay. There you go.
And I think also just to point out, like
Yeah.
I'm not sure if you mentioned this, but like we did want to keep it lightweight. We had a bit of discussion. Do we want to do a feature branch? And these data functions are pretty small scripts, a few kilobytes. Um, so we definitely use the Git flow process. We keep it very basic, just a branch and a master branch.
Mhm. Thanks, Neil. So as you can see here, so we have a master branch. We have nothing in there right now, but we have a lot of activity that's happening on the develop branch. And this is how typically our develop branch would look like. We have folder that basically has a bunch of demo data in there that helps the authors to test their data functions. And then here we basically have our root directory, and for Python, as you can see, we have quite a few things happening here. So if you just quickly look at what how this works. So to start off with, we have this README generator, and I think this is a great piece of work our team has done. Is how you could just build your data function, and what you would basically do is, if when you have your SFD file, you would just export it to a file, and you can basically just run this README generator on this or the script on that exported file that you have. And what that does is it just basically goes ahead and strips out all the descriptions in your SFD file and converts them into like this neat little README. So I'm going to show a quick example of that, of how that looks like. So let's say if you go for like a one-hot encoder, this is something that Adam worked on. As you can see here that, the SFD file, running it through the generator basically just yields this neat README file that shows, the data function inputs and the outputs in a neat README format. I was also
Yeah,
talking about.
like yeah, I was kind of hit on that and like just kind of swiftly explaining what this is. In GitHub, there's a .md file. You'll see that readme.md. It's good practice to have a README in every repository, every kind of project that you have. But we have a lot of repetitive stuff happening, and we don't want to keep writing that to each README file over and over. And then the SFD file, what the SFD file is, it's a Spotfire data function file, and it's essentially XML. So all the information you need about what are the input parameters or the output parameters, they're in this XML file, but they're embedded in all this XML code. So there's just a Python script that just extracts what is in that SFD file, what is in that Spotfire file, what are input and output parameters, what are the descriptions, writes it to an MD, and then we can just publish it rather than us having to retype everything. Yep.
Thanks for that, Neil. So one of the other things that we definitely had our developers agree with was creating this sort of like a simple design document, something that you could pretty much reuse for all the other documents or for all the other data functions. So this would basically be, think of it as a level deeper of what your README would look like. And this would basically be like, the summary, what the data function does, especially going around the execution and looking at some of the edge cases around scalability, error handling, and some of the test cases that these data functions have gone through. Things like, did we test on bad data? Did we look at empty data sets, or did we look at passing incorrect values? So just a deeper documentation on this. And we also have obviously the py file that enables other testers to come in and look at the code. And even if they want to test the data function itself, they could do that through a py file or through a notebook file itself. So this is how a data function would generally look like. Now, what I'm really going to do is, once you're done with this process, and this process is iterative, as I said, would have feedback from the team. The author goes back, embeds it, comes back in, and next it's kind of ready to move into this, the phase of publishing internally. So I'm just going to.
Yeah, so I'm going to jump a little bit ahead here, and then we can kind of come back and hit these points. I just want to show where we're going with this. There is a new flyout in Spotfire 11 that allows you to be more plug and play with data functions rather than having to go through a lot of menus to configure a data function. Yeah, let's go ahead and thanks, Bob. Yeah, we can just go ahead and show this.
Yep.
So there's a flyout, and if you can go ahead and click your column correlation data function, you'll see that there's all of this new metadata that's showing here, the descriptions, the input fields. It's a lot more friendly. This is actually becoming available on the web as well for business authors. And the goal is to kind of separate the personas, where you have developers that are data scientists that build data functions, and then you have casual analysts and consumers that want to use those data functions, or even other data scientists that want to use data functions written by others. And so how do we make that more plug and play? How do we just make that a more smooth process? And that's where this is all going. So I wanted to mention that in the past, if you're building a data function, you may not have put in the metadata around the description, what's the input parameter, output parameter, what's the description of the data function itself. So you may not have put that information in. But now I would actually recommend doing that because it's going to show up in this library. It's going to show up in this flyout, and that type of documentation is going to help others reuse it. And so we have used this practice. We have also created a data function library. Sorry to kind of hijack a bit there, Vaibhav, but I'll let you go ahead and finish off where you can show the repository of data functions we're putting out for you in the community, our users in the community, and you can start to use this.
Thank you. Thanks, Neil. So just going back to our landing page. This is our data functions library, and as Neil mentioned, that one of the things that we've done with these is to have a sort of a landing page where the community can actually come out and look at the data functions that the team has worked on. As you can see, we have a few of them in the field of geoanalytics, some on machine learning, and these could be a combination of R and Python, some on statistical analysis. And this is a growing page, so we keep adding data functions at a pretty fast pace here. So let's say if you were interested in the random forest Python, just basically come here. And then clicking on this should directly take you to the community exchange. And it's as easy as just going to releases and just downloading the zip file and taking the SFD and just registering it as a data function.
And what do we have in the pipeline, Vaibhav? We have like what, 20 new data functions?
Absolutely, yes. We definitely have quite a few in our pipeline, and these are these are roughly about, I would say about 15 or 20, but these are around, quite a few of them will be around, the upcoming data functions will be around deep learning. As you can see, some of them are TensorFlow based. We're also looking at some very generic data functions, which would focus more on data transformation.
Yeah, we're really excited about this. You know, the Spotfire data function framework is a very extensible and allows for this, and we're excited to be just pumping these out and just giving you new features in Spotfire without you having to do all the work. We're putting a lot of the core stuff, like I don't know if it's if PCA is one of these, but there's a few of these. I think some linear regression ones or regression trees we've done in both Python and R. And that's so that you can, if you're comfortable in Python or you're comfortable in R, you can take this code and you can build off of it yourself. So, thank you all for joining today's Dr. Spotfire. Thank you to our guest speakers, Vaibhav, David, and Adam. We really appreciate it. And we will see you all next month.